principal, for giving me this opportunity to organize and to deliver a lecture on this 2-week workshop on enriching problem-solving skills in pure and applied mathematics through online. So all the resource persons we have arranged so far our workshop are highly qualified, and they are all have cleared the CSIR, NET, NBHM and GATE exam more number of times. Also, they are very kind enough to share their knowledge and to motivate all of us to face the exam, a screening test. Myself, during 1995 and 1997, I have appeared for GATE exam. At that time, no one was motivated or trained us to face such exam. Now you have this opportunity to clear a lot of exposure on how to prepare and appear for the exam. Kindly make use of it and get success. Okay, with this few introduction, let me enter into the topic. So already our one of the resource person, Dr. M. Saravanan sir, have covered almost all the topics in statistics, followed by his lecture. Today I am going to discuss something about some basic concepts on standard distribution and some of the problems from CSIR and GATE. We have to discuss the problems. And also after that, I will discuss some of the topic from theory of estimation. While I go through the syllabus and the various question papers on CSIR, most of the questions are coming from estimation theory. The questions are repeatedly asked. That's why I have to give some small introduction about estimation theory. Right? Now, all are familiar with the standard distributions. We have discrete distribution and a continuous distribution. In discrete distribution, binomial, Poisson, geometric, and
ma'am, excuse me, ma'am. Your
yes,
screen
sir.
is not visible, ma'am. Ma'am,
Yes,
now it's
yes,
visible, ma'am.
Okay,
now
sir.
it's visible.
Okay.
Okay, ma'am.
See, binomial, the PDF of the probability mass function of a binomial distribution is probability of x equal to r is NCR p power r q power n minus r, where n and p are the parameters. Probability of n greater than or equal to 1 and the probability of pp is very 0, like 0 less than p less than 1. And some of the probability of success plus failure equal to p plus q equal to 1. Already all are familiar with the PDF. And mean of the binomial distribution is the parameter np, and variance of the binomial distribution is npq. And the moment generating function, remember the basic concepts. If you know all the concepts, then you can easily answer for some of the questions from binomial distribution. The moment generating function of binomial distribution is q plus p e power t the whole power n. Q plus p e power t the whole power n. And the binomial distribution is q symmetric if p not equal to q. If it is symmetric, only when p equal to q. Binomial distribution is symmetrical if p equal to q equal to 0.5. And in binomial distribution, variance of x is always less than mean. Variance of binomial distribution is npq, and mean of the binomial distribution is np. And so another sum of two independent binomial random variable or sum of two independent binomial distribution with parameter n1 comma p for x and n2 comma p for y. Then sum of two independent binomial distribution also follows binomial with parameter n1 plus n2 comma p, right? And the difference of two independent binomial, let me explain this one. Suppose Okay, sorry. Screen share. So with this introduction, first probability of x equal to r is NCR p power r q power n minus r, where r varies from what's a finite distribution. R varies from 0, 1, 2, etc. up to n. There are out of n trials, probability of getting r success. Out of n trials, probability of getting r success is given by NCR p power r q power n minus r. R varies from 0, 1 to etc. up to n. With p plus q equal to sum of the failure and the success equal to 1. Now, the first question here, x have a binomial distribution with parameter n and p with n greater than 1 and 0 less than p less than 1. It is given to be probability of x equal to 0 is equal to probability of x equal to 1. So we know what is the value of the problem is asked to find. Then what is the value of p we are going to determine. So you can write what is NC0, p power 0, q power n minus 0 for probability of x equal to 0 equal to probability of x equal to 1 is NC1, p power 1, q power n minus 1. And solving NC0, the value of NC0 on a p power 0, 1, q power n equal to, the right side is NC1 is n, np, q power n minus 1. Right? And solving from this, we get what is np, np cube throughout divided by q power n minus 1. So q equal to np or p equal to, we need n equal to so am I audible to you on? Yes?
Yes, ma'am.
Okay. Now tell what is the value of p?
1 by n plus 1.
S 1 by
N plus 1.
1 by n, S p equal to 1 by n plus 1. That's a simple one. Next, the second question. That is a question from CSIR part C. Which of the following are correct? X and y are independent normal random variable. Then x plus y by square root of 2 is a standard normal variable. Standard normal with mean 0 and variance is 1. And second option, x and y are independent. So remember, what do you mean by x and y are the PDF of normal random variable? What is it? X follows normal. X follows normal means x follows n of mu comma sigma squared. Then the PDF of x. The PDF of x is given by, so what is the PDF of x? 1 by root of 2 pi sigma into e power minus of x minus mu the whole squared divided by 2 sigma squared. Minus infinity less than x less than infinity. The PDF of normal random variable. Right? And then the PDF of standard normal random variable is z equal to x minus mu by sigma. X minus mu by sigma, this follows n of 0, 1, whose PDF is given by pi of z. So pi of z equal to 1 by 1 by root 2 pi sigma, 1 by root 2 pi sigma is 1, e power minus x minus mu the whole squared. So e power minus x squared by 2. And you are all familiar what is x and y are independent. If x and y are independent, then the joint density function f of x comma y equal to product of their marginal density f of fx of x into fy of y. Right? So for answering this question, wait a minute, I will show another slide. Is it visible? See, there are 4 options given. X and Y are independent normal. Then x plus y by root 2 is normal. X and y are independent. Then x by y has a t distribution. Yes. Hello. Okay, sir. Is the standard normal Z follows n of 0, 1. In order to verify the first result, we make use of the moment generating function. So what is the moment generating function of standard normal random variable? The moment generating function of standard normal random variable is e power t squared by 2. For a normal random variable, this is e power mu t. Here all we are discussed about standard normal. So remember, the moment generating function of normal random variable is e power t squared by 2. Now, remove some of the properties of moment generating function. Moment generating function m x of m ax plus, suppose ax plus b, a and b are constants. What is moment generating function of ax plus b? The moment generating function of ax plus b is e power bt into mx of at. E power bt into mx of at. Make use of this. We are going to apply here. X and y are independent. Then m ax, the n ax plus by, m ax plus by of t equal to m x of at into my of bt. If x and y are independent, the moment generating function is product of their MGF. So based on this result, I am substituting x plus y and 1 by root 2 is taken as c. So m x plus y of root 2 into t. So m x plus y of root 2 into t equal to m moment generating function of root 2 into t into m moment generating function for y, root 2 into t. Both x and y are normal. Whose moment generating function is e power t squared by 2. Here we are replacing this constant. The t instead of t can substitute t by root 2. Therefore, 1 by 2 into t squared by 2. So this is e power t squared by 4 into e power t squared by 4. On simplifying, we get e power t squared by 2. This e power t squared by 2 is the moment generating function of a normal random variable. Therefore, if x and y are independent normal, then x plus y by root 2. X plus y by root 2 is also a standard normal random variable. So the first option is correct. Similarly, how to say that the second option? Second option, x and y are independent normal. Then we are going to verify x by y. X by y as a t distribution. So for that x by y, x by y, we move to the transformation of random variable. X and y are independent normal. Now we are going to verify x over y follows t distribution. But x by y follows Cauchy distribution. Let me explain here. The PDF of x is 1 by root 2 pi into e power minus x squared by 2 for f of x. And f of y the same, 1 by root 2 pi into e power minus y squared by 2. F of x and x and y are independent. Then the joint PDF is equal to product of their marginal PDF. So we get f of x comma y equal to 1 by 2 pi into e power minus x squared plus y squared by 2. Both x and y are lies between 0 and infinity. This is the joint PDF of x into y. Now we are going to find what is the PDF of x by y. We have to verify what is the PDF of x by y, whether this the PDF of x by y follows t distribution or not. Right? For that, consider u equal to x by y. Use the transformation of random variable technique. You take u equal to x by y and let us take v equal to y. Then we have x equal to uv and y equal to v. While transforming the variable from xy to u comma v, what is the joint PDF of u comma v? The joint PDF of u comma v equal to mod of the Jacobian into the density function of x and y. Right? Here, Jacobian value. So we are determining Jacobian of u comma Jacobian of u comma v with respect to Jacobian of x and y with respect to u and v. You can determine Jacobian of x comma y with respect to u and v. So we differentiate partially with respect to what is dou x by dou u, that is v, and what is dou x by dou v, which is equal to u. And similarly, this one, what is Jacobian of dou y by dou u, equal to 0, dou y by dou v equal to 1. So Jacobian equal to v. That mod of the Jacobian equal to v into, here replace all the x and y in terms of u and v. Here e power minus of x squared plus y squared. So substitute x squared and y squared. X squared equal to u squared plus v squared, and y squared is equal to v squared. So we have e power minus u squared plus 2v squared divided by 2. This is the joint PDF of u comma v. From the joint PDF of u comma v to one can determine, so what is the density function of u in it, because the problem is asked to find x, y, y whether follows t distribution or not. So we are going to find the marginal PDF of u, integrating the joint PDF with respect to v. So here e power minus v squared plus this is 1, 2v squared. I made a mistake, this one. E power minus x squared plus y squared by 2. So x squared equal to u squared v squared plus y squared is 1, v squared. So v squared is common. There's some mistake I written. This is right. The next step corrected. Here e power minus u squared v squared, e power minus v squared. Both the term v squared is common. Take v squared outside. E power minus v squared into 1 plus u squared divided by 2. Whole thing divided by 1 by 2 pi a. Mod of the Jacobian is v. For the normal random variable, we have the limit is from minus infinity to both u and v are from minus infinity to plus infinity. Mod of the Jacobian, this term is positive, this is even, and here this v, this also v squared into 1 plus u squared. This term is also even. Therefore, I am writing this is 2 times integral 0 to infinity. This is an even function. Therefore, I am writing this as 2 times integral 0 to infinity e power minus v squared into plus u squared by 2 into v dv. While evaluating this integral by some substitution, I ought to choose this term v squared into 1 plus u squared by 2. This is taken as t. So the v and the t are considered as the parameter. Then an integrating, differentiate this one. What is dt? dt equal to 2b by 2 into 1 plus u squared, and then cancel. Then this integral becomes e power minus t dt by 1 plus u squared. So 1 by, we are integrating this with respect to t. So take this 1 plus u squared outside. So 1 by pi into 1 plus u squared. Integral 0 to infinity e power minus t is 1. So this is the well-known Cauchy distribution, which is not a t distribution. So the second option is wrong, right? So the x and y are independent. Normal. Then x over y, x by y follows Cauchy distribution, which is not a t distribution. So second option is wrong. And what is the third one? If x and y are independent, uniform, then x plus y by 2. X plus y by 2 is also uniform. So already, what is the uniform, or another name of uniform distribution is rectangular distribution. If x and y are, x follows uniform over the interval a comma b means the PDF of x. What is the PDF of x? It's a constant given by 1 by upper limit minus lower limit. So 1 by the upper limit, here it is given to be 0 and 1 only. So fx of x is 1 and fy of y is also 1, and x and y are independent in the sense fx and the x plus y, that is also 1. So using the same way, we can verify. The x follows uniform distribution PDF already I have given. And the mean of the, what is the mean of the uniform distribution? Mean of the uniform distribution is a plus b by 2. Variance of the uniform distribution, b minus a the whole square divided by 12. And the moment generating function of a uniform distribution e power bt minus e power at divided by b minus a into t. If u follows, you need a comma b. Instead of a comma b, in the problem it is 0 and 1 is given. So what is mx of t? Mx of t equal to e power t minus 1 by t. And then I am applying the same concept for the first one. How applying for normal? Mx plus y of t. X and y are independent, right? So this is of the form mx of t. Mx plus y of t to t by 2. Moment generating function of sum of two independent random variable equal to product of their moment generating function. So using the moment generating function property, I write this mx of t by 2 into my of t by 2. So substitute what is mx of t by 2? E power, instead of t, can substitute e power t by 2 minus 1. Here also e power t by 2 minus 1. So we have e power t by 2 minus 1 by t by 2, which is not in the form of e power t minus 1 divided by t, right? Therefore, this is not a uniform distribution. So, clear? Sum of two independent normal, standard normal is what it is, and sum of two independent uniform, not sum of two independent x plus y divided by 2. Once you can verify by using moment generating function concept, or otherwise we can verify it by the transformation of random variable technique. And the second option, second one, third one is wrong. And another option, if x is binomial, then what is n minus x? Then n minus x is, n is a parameter, x is a random variable, follows binomial. We are going to verify what is n minus x. Here, once again, we'll use the same concept, moment generating function. So what is a moment generating function? X follows binomial. Moment generating function is q plus p e power t the whole power n. Now what is m? Instead of this one, n is a constant. N constant minus x random variable. N minus x of t equal to e power nt into mx of minus 1 into t. In e power nt into mx of minus 1 into t. Right? So substitute e power nt mx of minus t. Here replace t by minus t, q plus p e power minus t the whole power n. So both the term we have e power t the whole power n. Here also q plus p e power minus t the whole power n. Allow e power t inside, we get q e power t plus p into e power t into e power minus t. It becomes e power 0 into n. So this is of the form p plus q e power t the whole power n. P plus q e power t the whole power n. So once again, this is in the form of moment generating function of binomial random variable. Instead of q and p, this p plus q e power t the whole power n. Therefore, this n minus x follows binomial with parameter n. Instead of p, this q. Binomial n minus x follows binomial with the parameter n and q. Or q, I can write 1 minus p. So the fourth option is correct. So among the four option, we have x and y are independent, means x plus y by root 2 is a normal. And x and y are independent normal, then x over y has a not the t distribution. It follows Cauchy. And third one is also wrong, since moment generating function of x plus y by 2. It's not in the form of moment generating function of uniform. And the fourth one is correct. Among the two of first one and fourth one is the correct. Next, move on to the next question. This is very simple. X and y be independent and identically distributed uniform random variable. Then what is probability of x minus 1 by 2 the whole squared? What is probability of y less than x minus 1 by 2 the whole squared? So how to find the value? Anyone? Anyone know the answer? You can tell me how to find it. How to find x and y are uniform. We know what is the PDF of uniform. Here the question is asked, determine or find probability of y less than x minus 1 by 2 the whole squared. X minus 1 by 2 the whole squared. So how to find this value? So here, fx of y, fx of x, it's a constant, uniform over 0, 1. It's a 1 in the interval 0, 1. And similarly, fy of y is also a constant PDF 1. Then once again, values of independent f of x, y equal to fx of x into fy of y. That is also 1. Both x and y varies from 0 to 1. Now, we are going to find what is probability of y less than x minus 1 by 2 the whole squared. So we make use of what is probability of y less than x. In order to find the probability of y less than x, make use of the double integral over this region. So double integral here, both x and y are varies from 0 to 1, but y is the upper limit. Upper limit for y is taken to be x minus 1 by 2 the whole squared. Take the upper limit for y, x minus 1 by 2 the whole squared, and integrate f of x comma y, integrate f of x comma y dy dx. We are integrating this one, integral over 0 to 1 for a fixed x, right? This y varies from lower limit is 0 and upper limit is x minus 1 by 2 the whole squared. Now you can easily integrate. So what is the integral value? We are integral dy equal to y. Substitute the limit 0 and x minus 1 by 2. So x minus 1 by 2 the whole squared into dx. This of the form x minus a the whole power n. Integral x power n is x power n plus 1 by n plus 1. Again you are integrating this x minus 1 by 2 the whole cube divided by 3. And substitute the limit 0 and 1. And we have the answer is 2 by 24 by 1 by 12. Is it clear now? Is it clear? How we are finding? Is it?
Yeah.
Okay. So we move to the next one.
Okay.
Yes. Any doubt? So you should remember all the PDF. Next. X1 and X2 are independent binomial random variable with mean equal to NP and variance equal to NP into 1 minus P or NPQ. Then the distribution of the random variable, there are 4 options given. The 4 options, let me write it. One minute. One of the options is Z equal to N1 plus N2 minus X1 minus X2. It's a binomial with mean N1 plus N2 into 1 minus P or the same. Z is a binomial with mean N1 plus N2 into P. And the third option, Z is a Poisson distribution. Z is Poisson. The parameter is N1 plus N2 into P. Right? So there are 4 questions, 4 options. One is to find binomial and another to Poisson with the mean. Poisson with mean N1 plus N2 into P or Poisson with mean N1 plus N2 into 1 minus P. So how to answer this question? Z equal to, this is given Z equal to N1 plus N2. N1 plus N2 minus X1 minus X2. How to verify? The mean of the distribution of the random variable is Z. Right? How to verify the Z is a binomial or Z is a Poisson? How to verify? So now only we have seen. So what is mz of t? Mz of t equal to n1 plus n2. Or you can take what is in the problem is asked, what is the mean of this one? Any idea how to find? Either you can use the distribution of the random variable z. So first of all, you can tell me what is the distribution is. What z follows? Whether z follows binomial or z follows Poisson. If z follows binomial means then what it is, not its corresponding mean, right? So how to find? So what is the previous first problem we have discussed? Y n minus x. X is a random variable. X is a binomial random variable. Then what is n minus x? N minus x is also a binomial. N minus x is binomial. So how to verify? N minus x is a binomial with the parameter. What are the parameters? What are the parameters? So among the four options I have given, but I have not typed it here. First one is Z is a binomial with mean n1 plus n2 into 1 minus p r. Or the same, Z is a binomial distribution with mean n1 plus n2 into 1 minus p. And third option is the same, Z is a Poisson with the mean n1 plus n2 into p. Or Poisson with mean n1 plus n2 into 1 minus p. The assumption that mean of the binomial is np, e of xi. So what is the expectation of, is it n1? Expectation of a constant is what? So what is expectation of a constant?
Constant itself.
So what about variance of a constant?
0.
What about, yes, variance of a constant is 0. And if x and y are independent, what about variance of xy, x plus y? Okay. Now other tell me. Okay, no problem. Okay. So now tell me what is z? Z flawless, whether z is a binomial or Poisson. Z is a binomial random variable or it's a Poisson random variable.
Binomial.
Yes, it is a binomial. So what is the mean?
Mean is NP here.
Mean, see, mean is NP. Here, minus of x1 plus x2. Okay. So the option is binomial with mean n1 plus n2 into 1 minus p. So the answer for this question is it equal to n1 plus n2 into 1 minus p. Okay. Now tell me this one, fourth one. The third question is also similar to the second question. X and Y are independent random variable. Both follows binomial with different parameters, n and m, with the same probability, right? Either P or P equal to some value is given. It's 1/2, this also 1/2 or something. Which of the following are always true? 2x plus 3y. 2x plus 3y follows binomial with the parameter 2m plus 2n comma p. Are you agree? What is 2x plus 3y follows binomial? Yes. So what about 2x plus 3y? So among the four options, 2x plus 3y follows binomial with 2m plus 3n comma p. One generating function for so what is the one generating function of 2x plus 3y? So what is the one generating function of 2x plus 3y? mx of 2t into my of 3t. So yeah, x on the binomial with probability is n. So this is q plus p e power t. Q plus p e power t the whole power. So different parameter. This is m equal to n. And another one my equal to q plus p e power 3t. Q plus p e power 3t the whole power m. M not equal to n. So m not equal to n. Therefore, we cannot write 2x plus 3y in the form of q plus p e power t the whole power 2m plus 3n. Right? We cannot write, one cannot write moment generating function of 2x plus 3y as q plus p e power t the whole power 3m plus 2n. So the first option is wrong. And what about the second one? Y minus x plus m. What is y minus x plus m? One generating function of y minus x plus m. Whether this follows binomial or not. Once again, use the one generating function concept. My of t into mx or mx of minus t. Mx of minus t. This m is a constant. So e power mt into this. Now simplify whether x minus y plus m follows binomial or not. Anyone?
Actually y minus x.
Yes, sorry. Y minus x only. Y minus x I written. One generating function. Y minus x plus m. Additional some constant I have given here. Y minus x plus m. My of t into mx of minus t. Right? E power mt into common generating function of y. Y is a what the parameters given? Y follows binomial with the m. Q plus p e power t the whole power m into my of minus t. This is q plus p e power t e power minus t. Q plus p e power minus t the whole power n. Can you get the result? Whether this follows p of m plus n comma p? I think this also. Is it right or wrong? The binomial. Now you can try. Conditional distribution of y given x plus y. That's one of the result. Conditional distribution of y given x plus y is a hypergeometric. That's the result. And what about the distribution of x minus y is symmetric about 0? Binomial distribution is symmetric. If x follows binomial, it is symmetric about p equal to q equal to 0.5. Right? So what about the distribution of x minus y, whether it is symmetric or not? Symmetric about origin. First option is wrong. What is the second one? Second option is also y minus x plus m. It is also not a binomial. Yes. X minus y plus m, whether it is a binomial or not.
Not a binomial.
Yes, first two option is wrong. What about the third one? Third one is a well-known result. What about the fourth option? Whether x minus y is symmetric about origin? As distribution of x minus y is symmetric about origin. Yes. So the last two option, conditional distribution of y given x plus y is hypergeometric, and the distribution of x minus y is symmetric about origin. Both are correct. See the next one. X be binomial random variable with parameter 11, 1/3. At which value of k this is maximized? So n equal to 11, p equal to 1/3. At which value of k this probability of maximize? So you can use what is probability of x equal to r, ncx p power x q power n minus x. Here substitute the value of k equal to 2, k equal to 3, k equal to 4, and k equal to 5. For different values, you can get what is probability and verify at which value this function is maximum. First nc2 p power 2 into q power n minus 2.
Shall
So
we
n
apply
equal
the
to 11.
concept of mode? Excuse me.
Yeah.
Shall we apply
Yes.
the concept of mode here?
Yes, you can apply the concept of mode also.
Mode is also a value for which function is maximum.
Yes.
Okay. Thank you, madam.
So the answer is 3 and 4. You can use mode concept, or directly you can use the probability of x equal to x. Substitute x instead of x, you can substitute k value. What is probability of x equal to 2? Find what is probability of x equal to 2, probability of x equal to 3, probability of x equal to 4, and probability of x equal to 5. Right? You can determine, we know p is given, p equal to 1/3 is given, n is also given, p known, p is given means you can find what is q, q equal to 1 minus p. Yeah. So we know all the values. Okay. So you can substitute what is probability of x equal to 2, x equal to 3. I think x equal to 3 and x equal to 4, we get the same value, maximum value. Well, compared to k equal to 2 and k equal to 5. Right? Okay. Verify it. And then
Ma'am, actually, we need to maximize that probability value now. 11
yes, 11
ck
11 ck
1/3 whole 1/3 whole
yes,
power
1/3
k
whole power k into
2/3 whole power
n minus
11
k.
minus
11,
k.
yes.
We need to maximize that function now, ma'am.
Maximize it. Okay. Differentiate.
So finding stationary point and then
that is also one method. Okay. There is also you can apply. Differentiate it. What is the differentiate with respect to k and equating to 0?
Yes,
and
yes.
then second derivative you can find at each which value it is. Second derivative is what? Minimum. Then only you can say that at that particular point, we have the function is, the probability is maximized. There is also another approach. Okay.
Okay.
You can differentiate it with respect to k. And then the fifth one, x and y are independent exponential random variable with mean 4 and with means 4 and 5 respectively. For exponential distribution, what is the PDF of exponential? The PDF of exponential, what is f of parameter lambda? F of x equal to lambda into e power minus lambda x. Lambda always positive, lambda greater than 0, x also greater than 0 and equal to 0 otherwise. This is the PDF of exponential random variable. F of x equal to lambda into e power minus lambda x. Now, what is the mean of the exponential random variable? How to find mean? E
Lambda.
of x is not lambda. Mean of x equal to, for Poisson only the parameter lambda, that is also discrete. Here E of x equal to 1 by lambda something. So integral x into f of x into dx. We are integrating this. The lambda integral e power minus lambda x. So what is integral e power minus lambda x? While integrating this one, 0 to infinity e power minus lambda x. So what is mean of the exponential? Then what is the mean of exponential distribution? Mean of the exponential distribution is I given the PDF lambda into e power minus lambda x. So x into f of x into dx.
1 by
So you can
lambda.
apply. Yes, mean of the exponential is 1 by lambda. Yes. Okay. Right. Then here x plus y is exponential with mean 9. First question is asked. X and y, whether this x plus y is exponential or not. What
Yes.
about x? Whether x plus y is exponential? X plus y is exponential. Huh? So what is x plus y? Whether x plus y is exponential, mx plus y of t. So what is the moment generating function of, what is the moment generating function of exponential? What is the moment generating function of exponential? This mx of t integral e power dx into f of x dx. Here f of x equal to e power lambda x. Take x out, so e power minus x into e power minus x into lambda minus t dx. The answer is 1 by lambda minus t. What is the moment generating function of moment generating function? 1 by lambda minus t. Is it so? Moment generating function of exponential. Make use of moment generating function. How to determine the volume of mean? So what is mx of t? Integrating e power dx into e power lambda x dx. So lambda by, sorry, I forgot to write lambda by lambda minus t, or you can write 1 by 1 minus t by lambda, or 1 minus t by lambda the whole power minus 1. In that way also you can easily write moment generating function of exponential distribution is 1 minus t by lambda the whole power minus 1. So this 1 plus t by lambda, next term t by lambda the whole squared plus etc. plus t by lambda the whole power r plus etc. up to infinity. Using this moment generating function, one can write what is the first moment, second moment, third moment about origin. The first moment mu1 dash, or what is mu? Mu equal to coefficient of t by 1 factorial in mx of t. That is e of x equal to 1 by lambda. E of x equal to 1 by lambda. And e of x squared. What is e of x squared? Coefficient of t squared by 2 factorial in mx of t. Coefficient of t squared by 2 factorial in mx of t. Using this also we can determine. So what is e of x squared? Here t squared, there is no. So 2 by lambda squared. E of x squared equal to 2 by lambda squared. Knowing the value of e of x squared and e of x, what is variance of x? Variance of x equal to expectation of x squared minus expectation of x the whole squared. Therefore, 2 by lambda squared minus 1 by lambda squared, which is equal to 1 by lambda squared. So mean of the exponential is 1 by lambda and the variance of the exponential is 1 by lambda squared. So here, what is x plus y? What about x plus y? Whether this x plus y is exponential or not, right? Sum of two independent exponential random variable follows gamma. Not, this is not what? Exponential. So remember, sum of two independent exponential random variable follows gamma distribution. It's not the exponential. So the first option is wrong. Similarly, what about the second one? Xy is exponential with mean 20. How to find xy? Once again, we can use transformation of random variable concept. Find what is the PDF of xy. Here we can make use of moment generating function concept. So second option is also not correct. What about third one? Maximum of x comma y. Whether maximum of x comma y is exponential, that is also not correct. Only one option is correct. That is minimum of x comma y. Minimum of x comma y is exponential. So in order to find the minimum of x comma y is exponential, we can write what is the probability. Write the probability of minimum of x1 comma x2. Take minimum of x1 comma x2 or x comma y. Probability of minimum of x1, probability of, I'm writing minimum of x comma y greater than x. So what is probability of x greater than x? Probability of x greater than x. If x is exponential, then what is probability of x greater than x? The probability of x greater than x is e power minus lambda x. This is the probability of x greater than x. That means integral, we have x to infinity of, the lower limit is x, upper limit is infinity. We integrate lambda e power minus lambda x dx. Right? And integrating this one, e power minus lambda x by lambda. Apply the upper limit, e power minus infinity 0. Lower limit is x. Therefore, already we have a negative sign is there. So minus of minus plus e power minus lambda x. So probability of x greater than small x equal to e power minus lambda x. Now we are going to determine probability of x1 greater than x. Since x and y are independent, so separately we can find what is probability of x1 greater than x and the probability of x2, or instead of say x and y. Probability of x greater than small x and probability of y greater than small x. So what it is e power minus lambda x and this term is e power minus lambda y. Are two different parameters given. Both x and y are exponential with parameter lambda 1 and lambda 2. Therefore, this becomes e power minus lambda 1 x. After the probability e power minus lambda 2 x. So e power minus lambda 1 x and e power minus lambda 2 x became e power minus of lambda 1 plus lambda 2 into x. E power minus of lambda 1 plus lambda 2 into x. Right? Therefore, minimum of x comma y. This minimum of x comma y is exponential. Minimum of x comma y is exponential. Because I'm going to write this is capital F of x. What is capital F of x? Probability of capital X less than or equal to small x. In that way, I'm going to write. We need what is probability of capital X greater than small x. 1 minus the complement and determine the density function. We're going to differentiate it. What is f of x? From capital F of x, differentiate. By differentiating, we get lambda 1 plus lambda 2 into e power minus of lambda 1 plus lambda 2 into x. So this is the PDF, right? That's why minimum of x comma y is exponential is correct. The other options are what? Not the correct one only, right? Are able to follow how we are determining this minimum of x comma y is exponential. Make use of the concept of distribution function, capital F of x. Capital F of x equal to probability of capital X less than or equal to small x. Here you can compute what is probability of minimum of x comma y. Minimum of x comma y greater than x n. The probability of x greater than x and y are independent, so separately we can find probability of x greater than small x and x to probability of x2, or you can write in the form of product of their probability, that is e power minus lambda 1 plus lambda 2 into x. Then compute small f of x from capital F of x. Small f, the relation between small f of x and capital F of x is small f of x equal to the derivative of capital F of x. So minimum of x comma y is exponential. That's it. Okay. Next step, let x be a random variable with certain distribution. If x has exponential, then median of x less than expectation of x. So what is median of x? If x is exponential, then what is the median of x? Anyone can remember? Tell me what is median of x? If x follows exponential, then median of x equal to ln 2, natural logarithm, ln 2 by lambda. And what is expectation of x? Now only we have seen expectation of x for exponential is 1 by lambda. And then comparison, what is median of x and expectation of x? What is the median of x and expectation of x? Median of x and expectation of x is median of x less than expectation of x is true. So the first option is correct. And then second one, x has uniform in an interval a comma b closed interval, then expectation of x less than median of x. Right? So what is for a uniform distribution, mean of the uniform distribution, what is mean and what is median? What is mean and median of uniform? What is mean? Mean of the uniform distribution, uniform over the interval a comma b. If it is uniform over the interval a comma b, upper the so mean of the uniform distribution is b plus a divided by 2. That is mean. And what about median? Here mean median coincide. Median also the same. Median is also equal to b plus a by or a plus b by 2. So for uniform distribution, mean equal to a plus b by 2 and median also equal to a plus b by 2. Therefore, the second option is wrong. E of x less than median of x. That's it, whole group. Right? Second option is wrong. And what about the third one? Third is true. Yes, third is true. Third is a trivial. It's a true. Variance of x is less than e of x. And what about the fourth one? X has normal distribution. Then e of x, expectation of x is less than variance of x. For a normal, ordinary normal distribution, what is expectation of x less than variance of x? Yes. Normal distribution, mean mu, variance sigma squared. But for a standard normal alone, mean 0 and variance is 1. So what about this e of x less than variance of x or not? For normal, for a normal distribution, mean, median, mode are coincide. Right? But I am asking about variance. Yes. So what about the fourth option? Third option is correct, x binomial. And the fourth option is also right. The first two options is wrong. Yes. It's a true only. Right. And next one is simple calculation only. You can compute x1 plus x2 plus x3 are independent and identically distributed random variable. It takes a value 1 and minus 1 with the probability 1 by 2. Then find what is e of x1 plus x2 plus x3 plus x4 the whole power 4. I'll leave this one. Next to come to the similar problem you ought to try. Next, I will give some small introduction about estimation theory. This also one can easily verify. Random variable x is uniform and x equal to minus 2 into log u. How to write the density function of x? How to find the density function of x among the 4 options, which is the density function of x? Right? Anyone know how to find it for the 10th question? First, see the 10th one and move on to the estimation. The random variable x, random variable instead of x, it is given to be u. U is uniform in the interval 0, 1. And x is written in the form of minus 2 into log u. We are going to find the density function of x. Instead of finding the density function, we can start with the distribution function first. So what is the distribution function? Capital F of x we can compute. So what is capital F of x? Probability of capital X less than or equal to small x. So here what is asked? Okay, capital X. So what is capital X? Capital X equal to, right, probability of capital X. Capital X is minus 2 into log u, minus 2 into log u less than or equal to small x, which is, right, probability of minus log u, probability of minus log u, or you can write probability of log u, probability of log u, or greater than or equal to, sign, change the sign, greater than or equal to minus x by 2. And then take exponential on both sides. And by taking exponential, this is probability of u greater than or equal to e power minus x by 2. Probability of u greater than e power minus x by 2. Right. So what is the probability of u greater than e power minus x by 2? One can write 1 minus probability of u less than or equal to e power minus x by 2. 1 minus probability of u less than or equal to e power minus x by 2. So u, what is u is given? U is a uniform PDF. U is uniform PDF. So 1 minus uniform PDF, there is integral. The lower limit for this is 0, and upper limit we are considered as e power minus x by 2. Upper limit is e power minus x by 2. PDF of u. What is f of u into du? F of u equal to 1 since u is uniform. Therefore, 1 minus integral du. Integral du equal to u. U limit 0 to e power minus x by 2. This is equal to 1 minus e power minus x by 2. Lower limit equal to 0. Therefore, capital F of x equal to 1 minus e power minus x by 2. Capital F of x equal to 1 minus e power minus x by 2. From this, what is small x? Small f of x. Small f of x equal to the derivative. The derivative become minus of this minus 1 by 2 into minus 1 by 2 into e power minus x by 2. So minus of minus become plus. Therefore, the PDF of x among the option 4, e power minus x is not correct. Second option 2 into e power minus x is also not correct. Third option is, this third one is correct. So you can go with determine the distribution function, right? So small f of x equal to 1 by 2 into e power minus x by 2. if x greater than 0. And all the other three are not correct. Right? Next, the estimation theory. In estimation, the main objective of statistics is to draw the inference about population from the analysis of sample that we are drawn from the type. The two important statistical inferences are estimation and the testing of hypothesis. Here, the theory of estimation was founded by Professor Fisher in a series of the fundamental paper around the year 1930s. The main important characteristics of estimators are unbiasedness, consistency, efficiency, and sufficient. How to verify? Some problem is asked, right? One problem is given. How to verify whether it is x1, x2, etc. xn is a random sample from a normal population. One statistic is given. So that d equal to 1 by n into summation over I equal to 1 to n xi squared is an whether it is an unbiased estimator or biased one. So in order to verify, first remember what is unbiased. An estimator T is said to be unbiased. Estimate from the population parameter gamma. Take the expectation of T, expectation of theta equal to the population parameter. Then we can say that this theta is the right unbiased estimate of the population. In a sampling, already we know what is sampling population with mean mu and variance sigma squared. Expectation of x bar equal to mu. Expectation of s squared is not equal to if a sample equal to E of s squared. E of s squared for small sample. E of s squared capital S squared equal to sigma squared. So what is capital S squared and the small mean deviation about mean? Xi minus x bar the whole squared divided by n minus 1 and small s squared equal to 1 by n into sum of xi minus x bar whole squared. So remember, so what is capital S squared, small s squared, that is E of x bar and all. Now, for unbiasedness, E of Tn greater than theta, then Tn is said to be positively biased. If expectation of Tn less than theta, Tn is said to be negatively biased, right? And the biasness amount, the amount of biasness is given by the difference V equal to E of Tn minus gamma theta. So in our first one, the first problem, let me explain how to verify whether this is an unbiased estimator of this population parameter mu squared plus 1. X1, x2, etc. xn, capital X1 lead. Capital X1, x2, etc. xn is a random sample. Small x1, x2, etc. xn is a random sample from normal population with mean mu and variance equal to 1. The problem is also to show that T equal to 1 by n into sum of xi squared is a unbiased estimator of this mu squared plus 1. In order to verify unbiased estimator, what is expectation of xi? Given expectation of xi equal to mu and variance of xi equal to 1 for all I. Now we can compute, right? So what is variance of xi? The relation is also we know. Variance of xi equal to expectation of xi squared minus expectation of xi the whole squared. And then compute E of T. E of T equal to E of 1 by n into T is given to be summation y equal to xi squared. Now take expectation is taken only for random variable. So you can take the sum outside independent of the sum 1 by n. Summation y equal to 1 to n. Expectation of xi squared. But what is expectation of xi squared? The previous line I have given what is expectation of xi squared. Expectation of xi squared equal to E of this one variance of xi plus E of xi the whole squared. So what is variance of xi? Variance of xi equal to 1 plus E of xi. What is E of xi? Mu. Therefore, we have this one. E of t equal to E of t equal to this one, E of xi squared, but this E of xi squared is variance of xi plus E of xi the whole squared. Variance of xi is 1 and E of xi is mean, so mean squared, mu squared. So 1 plus mu squared. How many times 1 plus mu square repeated? N number of times. So 1 plus mu square plus 1 plus mu square. So right, n into 1 plus mu squared. Already we have 1 by n outside. The n and the cancel, we have the answers. So we have proved E of t equal to 1 plus mu squared. Therefore, t is the E of t equal to the parameter. Therefore, t is called the unbiased estimate of the population made 1 plus mu squared. Similarly, you have to verify. Let me extend some other problems. The t is unbiased estimate of theta, then show that t squared is a biased estimate of theta squared. So you can compute E of theta, E of t squared. E of t is unbiased estimate of theta. We have shown that one. T squared is a biased estimator. Right? That means E of t squared not equal to theta squared. E of t squared not equal to theta squared. Therefore, it is biased. Next one. Sum of xi into xi minus 1. This also you can verify it. Xi into xi minus 1 by n into n minus 1 is unbiased estimated for theta squared. So take expectation of xi, the term, full term. What is the expectation of the term? And simplify, we get whether it is the result equal to theta squared or not. Theta into theta minus 1. If x1, x2, etc., xn are random observations on a Bernoulli variate x, it takes the value 1 and it takes the value 1 with the probability p and 0 with the probability 1 minus p. So we know sum of the Bernoulli trial, sum of the Bernoulli becomes binomial. Sum of x1 plus x2 plus xn follows binomial distribution. Yeah. Here, the problem is asked to show that sum of xi by n into 1 minus sum of xi by n is a consistent estimator of p into 1 minus p. So what is a consistent estimator? First, unbiased expectation of, I think, what is first? The necessary and sufficient for the parameter theta is said to be a consistent estimator. First of all, mean is for expectation of Tn equal to gamma theta, and the variance of Tn approaches 0 as n tend to infinity. Then you can say that Tn is a consistent estimator of the population parameter theta. So remember, sufficient condition for consistency is this. Expectation of Tn equal to gamma theta, and the variance of Tn approaches 0 as n tend to infinity. Then one can conclude Tn is a consistent estimator of gamma theta. Right? So here, one problem, X is Poisson with parameter theta. The only unbiased estimator of e power minus of k plus 1 into theta is T of x equal to minus k the whole power x. This is we are going to verify. T of x greater than 0 if x is even, and less than 0 if x is odd, in the sense it is given. So what is T of x minus k the whole power x? Take expectation of T of x. Expectation of T of x equal to T of x into probability of x. What is Poisson? Poisson is a discrete distribution whose PDF is given to be e power minus lambda into lambda power x by x factorial. Instead of lambda, here parameter is given to be theta. Poisson parameter is theta is given. So e power minus theta into theta power x by x factorial. Now you have to simplify this summation. E power minus theta is independent of the sum. You can take e power minus theta outside. E power minus theta into here minus 1 the whole power. Take k allow the k power x. So minus 1 the whole power x into minus 1 the whole power x into k power x theta power x. So k theta the whole power x by x factorial. So already we were familiar with what is 0 to infinity x power r by r factorial. This is e power lambda, e power x. So instead of x here, k theta. So e power, the minus sign is there, alternatively positive and negative. Therefore, the summation value equal to e power minus k theta. So already e power minus theta into e power minus k theta. So by e power minus of 1 plus k into theta. That's why we have verified this. We verified that T of x is a unbiased estimator for this parameter e power exponential of this e power minus of k plus 1 into theta. We have verified this is one. T of x is the unbiased estimator of that one. Consistency and Tn equal to T of x1 x2 based on the random sample of size n is said to be consistent estimator if Tn converges to the population parameter in probability, if Tn approaches for gamma theta as n tend to infinity, or in other words, Tn is a consistent estimator of gamma theta if for every epsilon greater than 0 and eta greater than 0, there exists a positive integer n greater than or equal to m such that probability of Tn minus gamma theta is less than epsilon, right? Or it tends to 1 as n tend to infinity. Our probability of modulus of Tn minus gamma theta less than epsilon is greater than 1 minus eta for all n greater than or equal to m. So remember the definition for consistency. And then in order to verify, how to verify? In the sampling, n of mu comma sigma squared, the sample mean is a consistent estimator of population mean. In order to verify it's a consistent estimator, we can apply the sufficient part. Mean equal to what is mean and what is variance. Expectation of t equal to the population parameter and variance of t equal to 0. Here x follows normal, whose mean is mu, variance sigma squared. And what about x bar? X follows normal. What is x bar? X bar follows right normal with mean mu and variance sigma squared by n. Variance equal to sigma squared by n. The expectation of x bar equal to mu and variance of x bar equal to sigma squared by n. Take the limit n tend to infinity, expectation of x bar. It's a constant only. We're taking the limit which is mu and limit n tend to infinity variance of x bar. So variance is sigma squared by n. this value, then by applying limit n tend to infinity, this term equal to 0. So variance of x bar equal to 0 and expectation of x bar equal to mu in the limiting form. Therefore, you can say that x bar is the consistent estimated for the population mean mu. Similarly, another problem with x1, x2, etc., xn are Bernoulli taking the value 1 with probability p and 0 with the probability minus p. Here, that has to show that sum of xi by n into 1 minus sum of xi by n is a consistent estimator of p into 1 minus p. In order to verify the consistency, expectation of what is this term? You can take expectation of this and the variance of this. Expectation of x equal to, and then what is variance of x? Right? Here, x1, x2, etc., xn are identical and independently distributed, Bernoulli variate with probability p. Then we know sum of all Bernoulli variate follows binomial. For a binomial, mean NP variance equal to NPQ. Now, take T. What is capital T? Let us take capital T equal to sum of xi. Capital T equal to summation over I equal to 1 to n xi. So then take expectation of T. Then what is expectation of T? Expectation of sum of xi. Right? So expectation of T. So this xi. This xi is not a normal random variable. Sorry, not a binomial. This xi is Bernoulli. Sum of xi follows binomial. That's why expectation of T equal to NP and variance of T equal to NPQ. Now, our problem is what is x bar? X bar equal to 1 by n into sum of xi. So expectation of x bar. What is expectation of x bar? You can take expectation of x bar equal to 1 by n into sum of xi. Instead of sum of xi, you can put np. N and it cancel. So it is equal to p. It is equal to p. X bar equal to expectation of x bar equal to p. Right? That is by taking limit also in probability. This is expectation of x bar equal to p. And what is variance of x bar? Variance of x bar equal to variance of t by n. And what is variance of t by n? N is a constant. It is 1 by n squared into variance of t. That is 1 by a squared. This a squared into variance of x. Variance of ax equal to. So here 1 by n squared into variance of t. The variance of t equal to npq. Since t is binomial, so n and get cancelled. So 1 pq by n. Take the limit. This approaches 0. So limit n tend to infinity variance of x bar 0. And limit n tend to infinity expectation of x bar equal to constant, that is p. Therefore, the given t into this is like x bar is a consistent estimator of p. Now, what about sum of xi by n into sum of 1 minus xi by n? So xi by n is x bar. That's 1 minus xi by n. And this term is x bar. So we are going to verify x bar into 1 minus x bar. So what is x bar into 1 minus x bar? It is a polynomial in x bar. It is a polynomial in x bar and it's a continuous function also x bar. And this x bar is consistent. Already we are verifying x bar since x bar is a consistent estimator of p by the invariance property of consistent estimator. By the invariance property of consistent estimator, right? X bar into 1 minus x bar is consistent means this bar. This is also right p into 1 minus p. So remember, based on the result, first verify for x bar is consistent or not. If x bar is consistent, then by invariance property of consistent estimator, x bar into 1 minus x bar is consistent estimator of p into 1 minus p. And efficient, what do you mean by efficient? Right? P is the most efficient estimator with variance V1 and T2 is another estimator with variance V2. Then the efficiency E of T2 is defined as E equal to V1 by V2. That means E cannot exceed unity. Here, how we are calculating EI equal to variance of T by variance of TI, I equal to 1 to etc. Pn. And we make use of the assumption that EI is less than 1 for all I. For example, for a normal, the sample mean x bar is the most efficient estimator of the population mean. And the efficiency of E in median for such a sample is given to be E equal to variance of x bar divided by variance of the median. Right? Variance of x bar. X bar is x is normal. The variance of x bar equal to sigma squared by n. And What is the median of the variance of the median? Median pi sigma squared by 2n, right? And then simplifying, we get 2 by 5, which is less than 1. These are the repeated questions I will ask, right? The sample of size 5 is drawn from normal population with unknown mean mu, and consider the following estimators to estimate mu. T1, T2, T3 are given, right? T1 equal to average of 5, and then T2 equal to x1 plus x2 by 2 plus x3, right? T3 equal to 2x1 plus x2 plus lambda x3 by 3, with the assumption that lambda is such that, assuming T3 is an unbiased estimator of mu, you can find the value of lambda. And finally, verify whether this T1 and T2 are unbiased or not. T1 and T2 are unbiased or not, right? For the first one can easily verify E of T1, take the average value, x1, x2, etc., x5. Summation are equal to 1 to xi. Since expectation of xi is mu, therefore, this is 1 by 5. I will then 5 times. So 5 mu by 5, which is equal to mu. And that means T1 is the unbiased estimator of mu. E of T1 equal to mu. Therefore, T1 is the unbiased estimator of mu. Similarly, you can verify what is E of T2. E of T2, take expectation of x1 plus x2 by 2. Use the property of expectation only. 1 by 2 into sum of xi. This x1 plus x2. This is mu plus mu. There is 2 mu. This is expectation of x3 is mu. 2 mu. This mu plus mu not equal to mu. There is simply as 2 mu. Therefore, T2 is not an unbiased estimator. T2 is not unbiased estimator. Similarly, assuming T3 is unbiased, we are going to find what is the value of lambda. So if it is unbiased means whose expectation equal to mu. Make use of this assumption, we can determine so what is lambda. Here, and substitute the value of expectation of x, we get lambda mu equal to 0. Lambda mu equal to 0, they provided the lambda may not equal to 0. That means only thing is lambda equal to 0. So lambda equal to 0 in the sense, so what is T3? What is T3? Lambda equal to 0, then T3 equal to 2x1 plus x2 by 3. Next, we are going to verify among the three, which is the best estimator. Among the three, which is the best estimator. In order to identify best estimator, compute the variance of all. Variance of T1, variance of T2, and variance of T3. For which one? Variance is minimum. You can choose. Right? Variance of T1 is minimum, or variance of T2, or variance of T3. Right? So what is variance of T1 and variance of T2? Once again, by the property 1 by constant, that is a squared. A squared is 1 by 25 into variance of x1, variance of x2 plus etc. variance of x5. Because xi's are independent, identically distributed. That means covariance of xi comma xj 0. Covariance becomes 0. Therefore, simply we have variance of x1 plus variance of x2 plus variance of x5. All are sigma squared. So sigma squared by 5 for first one, variance of T1. What is variance of T2? The same way you can find variance of x1 plus x2 by 2 plus variance of x3. For this one, 1 by 4 times variance of x1 plus variance of x2 plus separately variance of x3. So here 3 by 2 into sigma squared. 3 by 2 sigma squared. And what is variance of T3? Variance of T3 equal to 5 by 9 sigma squared. So among the all, right? Variance of T1, variance of T2, variance of T3, right? Among these three, which is least? So variance of T1 is the sigma squared by 5 is the least compared to the other 3 by 2 sigma squared and 5 by 9 sigma squared. That's why we are concluding that T1 is the best estimator. Sometimes the question is given whether the 4 option is given, whether T1 is unbiased or not, whether T1 is the best unbiased estimator. So find variance and you can verify it. Similarly, another problems also we have discussed. X random variable of size 3, mean and variance sigma squared. The three are the estimators used to estimate the mean value mu, but T1 equal to and T2 equal to T3 equal to. The same similar property are T1 and T3 unbiased. So right, so what is E of T1 and E of T2? Verify E of T1 equal to mu and E of T2 equal to mu, then conclude is unbiased. Otherwise, okay, right. Similarly, find the value of lambda, assuming this T3 is the unbiased estimator. Assume E of T3 equal to mu, compute what is lambda. After that, right? With this value of lambda, T3 is a consistent estimator or not, right? So what is a consistent estimator? Consistent estimator means variance of T. Variance of T or value approaches 0 or not. You can verify variance of T. Then starting. Yes. If x1, x2, etc., xn bar is always a consistent estimator of population mean mu. If there is a consistent estimator Tn of gamma theta, then infinitely many such estimators can be constructed, right? So Tn dash, if you consider Tn dash is equal to n minus a by n minus b into Tn, and taking the limit n tend to infinity Tn dash n minus a by n minus b. Anyway, this term you can write 1 by 1 minus a by n, 1 minus b by n. Anyway, this term, while applying the limit, this is 1 into Tn. Therefore, limit n tend to infinity Tn dash is equal to limit n tend to infinity Tn, limit n tend to infinity Tn in probability approaches population parameter gamma theta. Therefore, Tn is also consistent. Not only Tn dash is also consistent estimator for different values of A and B. The invariance property discussed. Next, see, in the unbiasedness and consistency, if you have any doubt, you can ask. I am unable to type all the questions here. No problem. Let me tell the problem. Page number 13. Oh, right. See here. Problem, right? Consider the linear model. Y1 equal to, it's a CSR question. Theta 1 plus 2 theta 2 minus 2 theta 3 plus epsilon 1. And Y2, another theta 1 plus 3 theta 2 minus theta 3 plus epsilon 2. And Y3 equal to theta 2 plus theta 3 plus epsilon 3. Yi's are observations and theta I are parameter, and both are what? Epsilon I are uncorrelated random variable with mean 0 and a constant variance. Phi equal to 1, 2, 3. Then which of the following is true? Which of the following is true? It is asked, right? Which of the following is true among all y1 plus y1, y2, y3 relation is given. The first one is 2y1 minus y2 minus y3. Whether it is unbiased estimator of theta 1 minus 4 theta 3. How to verify whether it is unbiased estimator? 2y1 minus y2 minus y3. Form the relation and take expectation of such value, expectation of the term. So what is expectation of y1? Expectation of y1 is theta 1 plus 2 theta 2, because they are parameters. Theta 1, theta 2, theta 3 are parameters. Only the term epsilon 1 is a right random variable. So which is the random variable? What is the random variable is given? Epsilon I is an uncorrelated random variable with mean is 0. Right? Expectation of epsilon 1 equal to 0. So only we have this is theta 1. Expectation of y1 is the same. Theta 1 plus 2 theta 2 minus 2 theta 3. Expectation of y2 also theta 1 plus 3 theta 2 minus theta 3, since P of A of epsilon 1 0, E of epsilon 2 0, E of epsilon 3 is 0. Now, so what is 2y1 minus y2 minus y3? 2y1. Can add the term. 2 theta 1, 2 theta 1, 2 theta 1, here minus y2 minus y3. 2 theta 1 minus theta 1. Here there is theta 1. Next, this is 4 theta 2, the 4 theta 2 minus y2 minus 3 theta 2 into a minus. So minus theta 2 minus 4 3 theta minus 4 theta. So theta to eliminate. So 4 theta 2 minus 4 theta 2, so no theta 2, only theta 1. Here minus 4 theta 3. This term minus theta 3, this is plus theta 3. Anyway, these two get eliminate. So theta 1 minus 4 theta 3. Therefore, 2y1 minus y2 minus y3 is an unbiased estimator of theta 1 minus 4 theta 3 because whose expectation of this term is theta 1 minus 4 theta 3. Therefore, it is an unbiased estimator. The first option is correct. Second one, 2y1 minus y2 minus y3 is the best linear unbiased estimator. This is best linear unbiased estimator or not. Best what we are going to tell. It is already the previous step. It is unbiased. Now what about whether it is variance? You verify whether it is a consistent or not. Whether it is consistent, then only can say that it is a best linear unbiased estimator. Similarly, you can compute y2 minus 3y3. Let me discuss later this one. Now compute what is y2 minus 3y3, whether it is unbiased or not. y2 minus 3y3. y2 minus 3y3. Right? That is also y2 minus 3y3. 3 theta 2. Theta to eliminate. Theta 1. Here minus 3 theta 3. Here also minus 4 theta 3. Anyway, the term that is y2 minus 3y3 is the unbiased estimator of theta 1 minus 4 theta 3. Now my question is whether it is best linear unbiased estimator or not. Whether it is consistent or not. Mean 0 and constant variance is given. So what about variance of this term? What about variance of this? E of y2 minus 3 into variance of y3 you can compute. So variance of a constant. Variance of a constant are all 0. Right? This is variance of y1. Variance of y1 equal to simply as variance of epsilon 1. Variance of epsilon 1 is constant variance. Let me take it as sigma squared. So this is sigma squared. And variance of y2 is also taken to be sigma squared. Variance of y3 is also sigma squared because this thetas are the parameter, a constant. Variance of a constant equal to 0. Only thing we have this one. Now, so what about y2 minus 3 y3? Variance of y2 minus 3 y3. For comparing this one, so what about their variance? Variance of this term y2 minus 3 y3 and variance of this term among these two, which one has least variance? Which one has the least variance? Based on that, we can conclude. Sir? Whether it is consistent or not, whether it is consistent or not. Okay, so with this I will stop my lecture. Such a type of question is repeatedly asked, right? Some relation is given and then, right, among all which is unbiased, which is a consistent estimator, which is a sufficient, right?
Okay, ma'am. Thank you for your nice lectures in this lecture series, ma'am.
Okay, sir. I'm unable to share my videos and all, sir.
Okay, ma'am. No problem, ma'am. This is look fine, ma'am. No problem.
Okay, sir.
Okay, ma'am. Thank you, ma'am.
Okay, thank you, sir.
Participant, any questions? You may ask.